back. Hector here from helpmegraduate.com. Second part of the series of exercises of the limits with polynomials. And like I said before, we're going to continue this series with another type of limits until we get to the point where we just see a limit and solve it without just labeling it. Okay? So without further introduction, remarks, what is it? I'm going to continue, and we were left with example number 3, right? Number 3. From my book, I have limit of x tending to 1, and the function is x squared minus 1 over x squared plus 3x plus 2. Oh, this looks a lot like the past example. So I'm already seeing the simplification. So it should be something like limit x tends to 1. On top, well, I'm going to have the rule that says x squared minus a squared equals x minus a times x plus a, right? So in this case, the a is 1, so I'm going to have x minus 1, x plus 1, and on the bottom, oh wait a second, what happened with the evaluation? Remember, the first thing you have to do before trying to solve the limit or rearrange the function or do the conjugate or the change of variable or this or that, the first thing you have to do is do the evaluation, okay? I cannot be this relaxed when explaining this, and I cannot reinforce this so many times, okay? I think I even told this story before. When I was in college, one of my buddies, he had a final, and it happened that the limit of the final was just a simple evaluation, but almost everyone in the classroom just solved, conjugate this, and that, and they just missed the fact that all they had to do was evaluate the limit, and that was it. So basically, almost the entire classroom, including my buddy, got the question wrong. So the first thing we have to do is evaluate, remember, okay? Evaluate. Evaluating, this means that on top I'm going to have 1 squared minus 1, and on the bottom I'm going to have 1 squared plus 3 times 1 plus 2. And this is equal to 1 squared is 1, and 1 minus 1 is 0, over 1 squared 1. 3 times 1 is 3, plus 2. 1 plus 2 plus 3 is 6. And 0 over 6 is 0. Whoa, now I have to do, let's see, well, limit, no, wait a second. 0 over something is 0, okay? 0 over something is always there. That is the answer to the problem, okay? We don't have to do anything else. But wait, isn't 0 an determination? No, 0 is a real number, okay? Again, if we graph the chart, okay, and I don't exactly know the graph for this function, but it's going to look something like this, as the graph gets close to 0, the value of the function is 0. That's it. That's what a limit is, okay? It's like the example of the past video where when the chart was getting close to 5, the chart gets close to infinite, okay? That's just what it is, okay? In this case, 0 is the answer, and I don't have to do anything else, okay? Are you sure? Yes, I'm sure, okay? We only have to work the limit when we have an indetermination, something like 0 over 0, infinite over infinite, okay? But 0 is a real number. 0 is the answer to the limit, okay? Remember, a limit is the value of the function when it gets close to the variable it's asking. In this case, when x gets close to 1, the function gets close to 0. So our fourth example. We're going to have, according to my notes, I have x tends to 2, x squared minus 2x over x squared minus 4x plus 4. Plus or minus? Plus. Okay? So, evaluating, the first thing we have to do, we're going to have 2 squared minus 2 times 2. Oh. 2 times 2 over 2 squared minus 4 times 2 plus 4. And this equals, well, 2 squared is 4 and 2 times 2 is 4. 4 minus 4 is 0. And at the bottom I'm going to have 2 squared is 4 plus 4 is 8. And 4 times 2 is minus 8. So 8 minus 8 is 0. Okay, this is an indetermination. It means that I have to rearrange the function, work on the function. Okay, now I have to solve the limit. Okay, so let's do that. Well, let's see. On top, I have an x that is common factor to both elements, so I can rearrange that. Let's do that. When I have something like x a, let's say x squared of a plus or minus x a, this is equal to having x common factor of ax plus or minus a. Okay? We can even do the a or whatever. Or we can even do the b. Okay, just common factor. So let's do that. Limit of x tending to 2. And on the top I'm going to have x that is common factor to x minus 2. Okay, you see? If I multiply x times x, I get x squared. If I multiply x minus 2, I get x minus 2, or minus 2x. Okay? What happens at the bottom? Well, I have x squared minus 4x plus 4. That looks like something I have seen before. Well, if you correctly recall, if I have something like x squared plus or minus 2xa plus a square, this is exactly as if I would have x plus or minus a, all of it squared. Okay? Do you see the resemblance? Well, in this case I have x squared minus 2 times 4 is 2 times 2 x plus 4, which is a square. So in this case I have x squared minus 2 times x times 2 plus 2 squared. And this can be re-expressed or rearranged as x minus 2 squared. Okay, see? In this case, a is 2. X squared, minus 2, x, a 2, a squared, a squared. So it can be rearranged as x minus 2 squared. So, x minus 2 squared. Okay? And I can simplify now. I can get rid of the factor, one of the factors, if x is not 2, and it's not. So this factor goes away, my marker. This factor goes away, and one of these goes away. This is a square, so I'm going to still have one left. So after simplifying that, I'm going to have limit of x tending to 2. On the upper part, I'm going to left x, and at the bottom part, I'm going to have one factor of x minus 2 left. So it's going to have x over x minus 2. And now I can evaluate and see what happens, okay? I can evaluate because I got rid of the indetermination of one of the factors, okay? 2 on top, because x2, and 2 minus 2 is 0. So I end up having 2 over 0. and this is infinite. Oh man, I have to do another thing to the limit? No, wait, again. This is the answer to the problem. Okay? Infinite, well, it's not a number per se, but it is an answer to the limit. Okay? Again, if I were to graph the function, when x gets close to 2, the function gets close to infinite, okay? And we can even do that. Where? Well, I'm going to have to erase this. And I can do it right here real quick, okay? If this is the y-x-axis, and when f gets close to 2, when f gets close to 2, f can be whatever, but when it gets close to 2, it takes off. And it goes to infinite. And that's what happens, okay? It's like the tangent function, or the example we had in the past function before. This is the answer to the limit, okay? Don't be afraid because you got an answer in the limit like 0 or like infinite or even minus infinite, okay? Those can be perfect answers to your problem, okay? To your exercise or to your final, okay? As long as you have the procedure fine, which we do, as long as we did the right thing, which we did, the answer, if it's infinite or 0 or whatever, that's the answer. Just trust yourself. Believe yourself, okay? Let's do a third example. It's going to be real interesting. Well, fifth example in reality. And I'm going to erase this to make it even clearer. This being organized. And there we go. Example number 5. Number 5, we're going to have limit of h tending to 0. What was the example? Okay. X plus h squared minus x squared over h. Okay? Tricky example, but it's fun and you will learn a lot of it, okay? And more importantly, we were going to see more of this in further videos. You will see when, okay? Well, I have to evaluate x and first arrow, okay? What is the variable in this case of the function? Is it x? Really? Take a closer look. Is it x? No, it's h. The variable in this case is h. X is whatever, a constant. Doesn't matter. The variable here is h. Okay? The variable of the function in this case is h. Okay? So I have to evaluating h tending to 0. I end up having, on top I'm going to have x plus 0